Hi, in the previous section, we looked at what it means, what we mean by digital signals, right? We looked at the difference between analog and digital signals. Now, if you have a system in which the amplitude scale is not continuous but is discrete, right? So let me just draw that here. So what I'm saying is that if we have a signal where the amplitude scale can only take certain values, there are discrete values that it can take, then what I can do is instead of uh, what I can do is I can represent each of these levels by a certain number, right? So I can, for example, call this 0, I can call this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on and so forth. And then the processing of the signal basically is processing of a few numbers. So you add the numbers, or you divide the numbers, or you subtract the numbers, or do something with those numbers. Now, that's what we do in digital systems. So, in one sense, if you want to think about digital systems, you can think about digital systems as if they are systems in which the signals are represented by arrays of numbers, right? So, as the signal is digitized, as the analog signal is converted into a digital system, you will have an array of numbers. So, let's say A1, A2, A3, and so on and so forth. And you want to take these numbers and you want to process them and derive some information from these numbers. Now, what we have found over the over some time in the world of electronics is that it is much easier to represent these numbers in a binary system. Okay, now what is a binary system? Now, the normal number system that we use in everyday life when we do maths is the decimal number system, isn't it? Now, what do you mean by the decimal number system? Now, what you mean is that you use 10 as a base for your numbers. Now, what do I mean by that? And I'm sure all this is familiar to you, but I'm just doing it because so that I can introduce binary numbers. And it's possible binary numbers are also familiar to you, but just bear with me, okay? So let's. So if I write a number in decimal called 728, what do I mean by that? My daughter is in grade 3, and she is learning how to write numbers in their expanded forms. Okay, it's very basic, right? 728. What do we mean by that? We mean this is 700 plus 20 plus 8. Each of these numbers, 8 and 2 and 7, represent slightly different things, right? 8 represent the number of ones in the number, 2 represents the number of tens, and 7 represents the number of hundreds. So you can write this as 7 times 10 to the power 2 plus 2 times 10 to the power 1 plus 8 times 10 to the power 0, right? So can you see that you are using 10 to represent the number, and if I had a thousands number, that would be 10 to the power 3, and so on and so forth. Okay, binary number systems are number systems where the base that we use is 2. Okay, the base is 2. Here the base was 10. In binary number systems, the base is 2. So if the base is 2, what are the numbers that can come in the system? You can only have 0 and 1. There are only two digits, or two digits that you can have in the number, two distinct values that you can have in the number system. When you have the decimal number system, since you have the base 10, then you can have 10 distinct values, and those are 0 to 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9, right? So in the binary system you can have only zeros and ones. So if I write a number, let's say called, let me write it in black here, let's say called 0, 1, and let's make it a little bigger, 0, 1, 0. Okay, what do I mean by that number? What I mean is 0 times 2 to the power 3 plus 1, which is this one, right? 1 times 2 to the power 2, and the other one gives me times 2 to the power 1 plus 0 times 2 to the power 0. And whatever that value is, in this case it turns out to be 5, isn't it? Oh, sorry, 6. So if I write this in decimal, that is 6. Now this is in 6 is not defined in the binary number system, but that's the decimal equivalent. So let me just write it as equivalent. Okay. Okay, so in digital systems, we generally use the binary number system. And why do we use the binary number system? Now let's think about this. If you have a system, and let's say the range of your system, the power supplies of your system is 0 volt, 0 and 5 volts. Okay, and what you say is, well, here's what I'm going to do. Any voltage above 3.5 volts, and in this range 3.5 to 5 volts, I'm going to consider it to be a 1. Okay, and any voltage between 1.5 and 0, this range, I'm going to consider it to be a 0. Okay, and now I can process the signal in my electronic systems and use these zeros and ones, and I can easily convert this 0 into a 1 by some kinds of circuits, and we'll look at those circuits, and the 1 into a 0, or do additions and things of that kind. But the important thing that we gain by doing this, assigning the value 1 to this big range of values, is that you get noise immunity, right? So if you had 5 volts, and because of some noise, that 5 volts actually becomes 4, let's say 4 volts, it doesn't matter, because in the digital system it's still going to remain 1. And similarly, let's say you have a value 0 volts in your system, and because of some noise it goes to around 1.5 volts. It doesn't matter, that much, no, the system can tolerate that much of noise, and all those values from 0 to 1.5 are going to be mapped on and called 0. Okay, so just as a summary of this video, what we are saying is, most digital systems, in fact, all digital systems, I can't think of any digital system that I've ever heard of that doesn't work on these principles, uh, works on binary number systems. Okay, which means that they have only two different values, 0 and 1, and they use 0 and 1 to represent all kinds of numbers. Now, just want to modify the statement. I think there are complicated systems that probably use that could use other number systems, but they are not at all common. Very, very, very rare.